All right,
All right.
welcome to another show here. Got Walker, got me, and we were talking, and we thought it'd be cool to explore tools that make thinking and analyzing the world easier, faster, better, more accurate. And one I thought of today, I think is really useful. It's kind of a nice introduction to this topic. It's called the Rule of 72. Have you gotten into this before, Walker, or had heard about?
I haven't heard of the rule of 72. This is the first.
Okay, but you like the idea of these mental models as a topic for us to talk
Of
about.
course, yeah.
Yeah. Okay. A couple episodes ago, we talked about reasoning from and designing from first principles from Elon Musk. Also, on that same show, we talked about process optimization, which is
Yeah.
not the same at all as reasoning from first principles, but it's, using a framework of how to think about things so you're not
Yeah.
just doing things in the wrong order. So,
Yeah.
continuing that kind of trend, really the idea is it can give you two different ways to help you determine the expected doubling period of an investment or help you figure out the required rate of return you want on your investment.
Okay.
Investment. So you might say, I'm getting a certain rate of annual growth rate. How long is it going to take for it to double? Or I want it to double in 10 years, as just an example. What is the annual compounded growth rate I need for it to double? So you could do the math on that, or you can just know that this is like a quick tool where you can get pretty close within a good ballpark if you have this rule of 72. It was invented by this Italian guy. Let me look up his name real quick. Italian Luca Pacioli. And he was referenced this first in his mathematics book called Summa de Arithmetica, 1494. Columbus, 500 years ago. Yeah. So, and I went and looked at that book. I'm like, oh, okay, this is cool. It's all in Italian, but it had all these it had algebra, it had first mention of double ledger bookkeeping.
Yeah.
I might have to run that book up just for fun.
That would be cool.
Yeah. So it's been around a long time. Let's look at it. Okay, a couple examples. So this can go pretty quick, but once you see things like this, then you're just like, oh, what else? What other mental models can I learn? Because that was amazing.
Yeah.
Yeah. Okay. So Walker, let's just say you wanted to, here's a couple of criteria that are needed for this to work. It needs to be a compounded annual growth rate, meaning that the interest will say, if it's 5%, is added to the principal of, let's say, $100, but you earn 5% interest, then that 100 becomes 105 for the next year of compounding.
Yeah.
So it's exponential, right?
Yeah.
Okay, that's important, and it works between kind of 6 to 10% annual compounded growth rate. And if it's
Okay.
than that or less than that,
Then it doesn't apply.
It does just have to make some little changes. So instead of rule 72, it's like rule of 73 or 4 or 5, but it doesn't. It's not a major difference. So
Okay.
if you were interested in that, look into it later, but we'll just stick to kind of the intro level right now.
Sounds great.
Okay. So if we were to say, how long will it be before my investment doubles? If it's growing at 4% annually, compounded.
How do we do it?
Well, it doesn't sound like that's very, like, how many, 4% a year? You might go like 400, 120 times, 25 times, maybe 25 years. I don't know, like maybe that's how you think about it.
Yeah.
But we can just use the rule of 72, which is take 72 and divide that by the expected rate of return, which in this case is 4.
Okay.
4% a year compounded. In this case,
So it's like 18 or something?
take 18 years to double.
Yeah.
Okay. Like, you can say that's exciting or not exciting, but the part that's exciting is the quick math.
That is cool.
And
Yeah.
So let's just say, what if it was 8% a year, which is what people use for, like, the S&P stock growth, when managers are always saying, like, just put it in the S&P and it's compounded 8% per year for the last 30 years on average.
That's like 9 years, right?
70,
Oh, the money is 9 years.
72 divided by 8%, or 72, the rule of 72, take 72 divided by 8%, which is annual growth rate. If compound, it would be doubled in 9 years.
Yeah.
Pretty cool.
That is really cool.
If it was 10% a year, then it would double in 7.2 years.
Yeah.
Like,
That's a nice little, I don't know, a nice little shortcut.
yeah. So we can also go the other way. Let's just say we wanted to take how many years before my investment doubles. It's the same thing, just kind of going, asking a different question.
How many years until my investment doubles?
If you want it, if you
If you want to double it in 10 years, how
double it in 10 years,
what percent do you need?
Need to be, thank you, yes.
7.2.
Yeah. Now that in that rule, it's easy because I divided by 10. But
Yeah.
if you wanted to double in, I think they're pushing the limits of the model, but it's still directionally correct. If you want to double in like 6 years, what would your annual compounded growth rate need to be? It's 12.
Okay.
So if you wanted to investment to double in 6 years, you have to get annualized return of 12%.
That's cool.
I mean, any time period would work. If you wanted to, if this was months and you had some crazy compounding system, like how many months would it, if you're compounding monthly, for example? I don't know what you have that's compounding like 10% a month, but if you have it, let me know.
I'll let you know.
Yeah. Anyway, that's it. And then like, the last scenario that would be kind of useful is you can use this in reverse to figure out how many years before your money loses half its value due to inflation in this example.
Yeah.
Because you always think inflation is only 2% or 3%. That's what you hear, right? And we hear we need it.
Yeah.
And let's not say it's good or bad. Let's just say like we have it. And if it is at 3%, how long before that amount of money loses half its value?
It's outside of our 72, but like 23 years, something like that.
Take 72, divide it by the rate of inflation, which is, you said 3%. And
Yeah.
Okay. So if you're getting 3% a year on your money, you would come out, kind of even. But let's take it a little farther. Let's say it's inflation rate is like 6%. So you would lose half of your money in 12 years.
Whoa, that's crazy.
You wouldn't think that. Just
No.
percent doesn't sound like I'm gonna lose half my money.
No, because people hold their savings for that long. They
Yeah.
don't think about that.
So yeah, it brings up some other questions like what should you do with money or savings if you are in an environment where you have inflation and debasements of currency, which we do.
Yeah.
So yeah, rule of 72.
That's cool.
So,
Like
3
that.
simple use cases for it, and there's others, but I thought that was a nice introduction to mental models.
Yeah.
Yeah.
I definitely like that one a lot.
Yeah.
I will be using that one more often.
Yeah. And then it will look like an all-star if you pull out Luca Pacioli. 1494 as part of that discussion. Yeah. It was Luca.
Oh yeah. Luca Pacioli in 1442 told me about this. Discovered this.
Yeah. Okay. All right. I think that was great. I think we should leave that one there for today.
That was sweet. I like that. It's useful. Yeah.
I think we should do more of those because, think that's super useful. And think of like, if there's other ways to view the world that are kind of shorthand like that, it just saves you time and like helps you make better decisions.
Yeah, it does. And it gives you insight you might have not worked for. Like I have never pulled out a calculator and done the reverse inflation, whatever, how fast so your money's worth half. But now I can just figure it out.
Yeah, that's great. Okay. Well, guys, I hope you enjoyed that one. Walker, I think that was great. We should do more of these. So I'll
Yeah.
be on the hunt for other mental models that we can put into a show. And if you guys want to follow along, like, subscribe, and also check out notnormal.com and
Go check it out.
get your free magazine. Okay, thanks, Walker. I'll see you on the next show.
See ya.
Bye.
Bye.